Namaste. Welcome to this channel Chemistry Made Easy by Dr. Ashok. We were discussing these theories of acids and bases, and we have seen the introductory part and the first two theories also, that is Arrhenius theory and state law concept. Now the third concept is solvent system concept. Solvent system concept. So this is different from that previous two, and it is restricted to some of the fields. So we will see first what is meant by solvent system. Solvent system. So the solvent system is the solvent which undergoes auto-dissociation or self-ionization, as a result of which it produces a cation and anion. So in short, we will show this like this. So if we take that this is a solvent, so after auto-dissociation it is converted into a cation plus anion. Cation and anion. For example, we can take our simple example of water. So we have to take two molecules. So these are undergoing self-ionization and produces H3O plus another ion OH minus. So this H3O plus with the H2O is solvent. H3O plus is cation and this OH minus is anion. Therefore, it becomes a solvent system. Another example we will see that is BrF3. So this also undergoes self-ionization or auto-ionization and produces BrF2 plus and BrF4 minus. So these are also this is also the example of solvent system concept. Here BrF3 two molecules will undergo self-ionization, means we will require 2 moles, or in other words we can say 2 molecules. So they will exchange their F minus. So one molecule of BrF3 will lose the BrF minus to another molecule, and as a result they will produce BrF2 plus and BrF4 minus. So one is cation, another is anion. So one example is of the solvent called protic type, protic solvents. Another example is of aprotic solvents. So we have given 2 examples of the solvent systems. Then we can use, so these are the solvent systems, and we can use the solutes in order to carry out the certain reaction or observe its acid-base behavior of the solvent. So as in this case, you will see if we add certain solute, that is salt or compound, to this water, and if that solute produces more number of H3O plus, means increases. So the solvent itself produces H3O plus and OH minus. This is okay, but in addition to that, after dissolving the solute in water, if the solute results or causes increase in the concentration of H3O plus, then that solute is called acid. So acid is the solute which when dissolved in water produces more or increase the concentration of cation, and the substance when dissolved in water, if it produces OH minus in more number, then it is called a base. Similarly, if we are using this aprotic solvent and if we also add a solute, because of which the cations are produced in more concentration, then it is called acid. and if the anions are produced in more concentration, then the substance is called a base. So in this way, this is the simple definition of the solvent system. So acids and bases are actually solutes, but when they are dissolved in a suitable solvent, then they can behave in order to produce the more number of either cations or anions, and depending upon that they are considered as acids or bases. So we can consider, say for example, if we take this solvent and if we add say H2SO4, we use as a solute, plus H2O as a solvent, and after this produces H3O plus HSO4 minus. So when H2SO4 is dissolved in water, this solute releases H plus to this H2O, as a result of which it produces cations in large number and anions in small number. Therefore, this solute is called acid. So this solute is called acid. Similarly, if we are having any other solute which can produce a anion also, so we can take another example of solvent, that is BRF. So we have seen the dissociation, auto-dissociation of here we have shown the auto-dissociation which results in the formation of cation and anion. Now if we take the solute, SbF5 plus BrF3, SbF5 plus BrF3, then if it gives here BrF2 plus SbF6 minus, SbF6 minus. So here it shows that the solute, this is a solute, this is a solvent, this is cation, this is anion. You can know this. But when you see that this solute is dissolved in BrF3, so it shows that there is increase in the concentration of BrF2 plus, and therefore it is acid. Now if we consider another example, if we see the Kf is a solute and BrF3 is a solvent. So after atomization, so we can show this, that after a reaction it produces this BrF4 minus plus K plus, BrF4 minus plus K plus. So here you will find that this solute is a base because it produces more number of anions. So anions are more. Here cations are more in this case. Therefore, this SbF5 is acid and this is a base. So after reaction or dissolving it into BrF3, it produces BrF minus and K plus. So the anions are in larger number. As a result of this, we have to consider this Kf as a base. So here we can have such a large number of examples. So the acid-base reaction in the solvent system can also other means we can consider that such reaction is the reverse of auto-dissociation. For example, the acid-base reaction means this is a acid. If we write this right side part on left side and left side part on right side, you will find that H3O plus reacts with OH minus to give H2O, twice H2O. Similarly, BrF2 plus reacts with BrF4 minus and produces twice BrF3. So this is called the reverse reaction, that is acid-base reaction. Means acid-base reaction is the reverse of auto-dissociation. Now, if we compare, now here in this reaction you will also see the same thing. Now, if we compare the acids and bases by different concepts, means according to Arrhenius we know that as per the such reaction, the acid reacts with base to produce salt and water. According to Arrhenius concept, acid reacts with base to produce salt and water. For example, HCl plus NaOH gives H2O plus NaCl. So similarly, we can have another Bronsted-Lowry concept we have seen earlier. So that shows that when acid reacts with base, it produces acid, means two pairs of acid and base. So it gives two conjugate pairs of acids and bases. For example, if we see the reaction between HCl and NH3, or you can take another example, any other example, then it will show the formation of two pairs, acid 1, base 1, acid 2, base 2. So we can get two pairs of acids, conjugate pairs. Solvent system shows that cation means acid reacts with anion and gives a solvent. So this is the difference between Arrhenius concept, Lowry-Bronsted concept, and this solvent system concept. So you see here that after reaction between cation and anion, that is acid and base, there is formation of a solvent. Now, here you will find the table which shows the properties of acids and bases according to the different concepts. Protic solvents. So these are the solvents containing proton. So you will find here H2SO4, HF, water, acetic acid, methanol, NH3, acetonitrile, etc. So these are the acid cations formed after dissociation. These are the base anions formed after dissociation. These are the pKa values and these are the boiling points. Now you will see that boiling points are given in order to consider what is the suitable range of that solvent where we can make use of that solvent for carrying out certain reaction. So if the boiling point is 330 degrees centigrade, we have to use that solvent only for the reactions that can take place around this or near to this boiling point. We cannot exceed the temperature range beyond the boiling point because the reactions cannot be carried out. So these will help us to select the range for carrying out reactions of suitable solutes in the specific solvent. Now this is the pKa value. So these are auto-dissociation constant values for the specific solvent. So this will help us to consider which of the solvent is more stronger and weaker. You will find here that the H2SO4 has pKa constant 3.4, which is the least smallest value of the solvents given here. So therefore it is the strongest acid. So this smallest value of pKa and this auto-dissociation constant indicates that it is the strongest acid of all. And if we find the largest value is here of acetonitrile, and therefore acetonitrile is the weakest acid. So in this way we can compare the strength of the acid and base or acid here, and also similarly base value. So smaller the value of pKi, stronger is the base, and larger the value of the pKi, it is the weaker base. So in this way we can find out or compare the different acids. So look, you can compare here depending upon the values given. Now we have to take sometimes caution, or we have to take care that behavior of the solvent or solute is important here. So sometimes the reaction may be misinterpreted. For example, we know that the SOCl2, the reaction between SOCl2 and SO3 minus. If we take the reaction, that is SOCl2 plus SO3 minus, then you will find that the product is SO2 plus. Sometimes the product is given as SO2 plus plus the product is here, it is SO2 plus. This solute contains SO2 plus ion, therefore it is acid, and this is a base. But after reaction it gives a solvent that is twice SO2, twice SO2 plus twice Cl minus. So this is, you can say this is reaction 1, and it shows that the formation of SO2, that is the solvent ion, is produced here, and therefore sometimes it is believed that the SOCl2 is acid. So reaction, we can say this reaction shows that the SOCl2 dissociated to form SO2 form. So this is expected to dissociate into SO2 plus twice Cl minus. So this is our observation or expected reaction. We can show this dissociation here. We can show that this is SO2 plus twice Cl minus. So it is expected, this SOCl2 is expected to dissociate into this SO2 plus and twice Cl minus. So this is acid. Therefore this SOCl2 is considered as acid. But sometimes the reverse reaction is or should take place. The reverse reaction should sometimes lead to show exchange of the oxygen ions. Oxygen ions may take place or show the exchange of the ions. For example, if we show the reaction, acid-base reaction, that is SO2 plus SO3 minus. So this is expected to, this is giving twice SO2. So this is easily observed, but actually what happens, this oxygen is exchanged with this sulfur, means this oxygen and this oxygen is exchanged, means this is replaced by one of these oxygens, means this oxygen comes here and any other oxygen goes here. So we can form along with, means one oxygen comes here and two oxygens goes there. So we get one molecule of SO2 and another molecule of SO2 with exchange of oxygen. But the observation of these reactions is not uncertain. It is not found as per expectation. So we can see that the dissociation is taking place in different manner. So we can observe that this reaction SOCl2 plus SO32 minus is expected to form SOCl plus 1 plus SO one chlorine is going here. SOCl means one oxygen is exchanged here. That is SOCl plus 1 and Cl minus. So only one, we will see the only one without this. Only this dissociation. SOCl minus. Means one chlorine is left with SO and another chlorine moves away. So we can get this, this is with plus sign. SOCl plus Cl minus. So this sometimes this type of reaction is also observed. So this is expected to be more feasible reaction. Then you can see the another type of solvents are aprotic solvents, where there is no proton in these solvents. So you will find that the molecular formula which doesn't have any proton. So they are called aprotic solvents. And we have given these boiling points in order to consider the suitability of that solvent for actual use in the reaction. So any certain reaction. So we can, depending upon our requirement, we can make use of these different solvents. So this is about the aprotic solvents. So with this we will stop our discussion and we will see the next point, that is another concept, that is Lewis concept, next time. So till then, goodbye, see you next time. Please subscribe to this channel and press bell icon and like button. Thank you very much.